Hello everybody. Now today I am going to teach you what is trapezoidal control techniques present in synchronous machine or permanent magnet synchronous motor in detail. One of the simplest method of the control of a permanent magnet synchronous motor is trapezoidal control. The trapezoidal control is used to control the permanent magnet synchronous machine with trapezoidal back EMF. At the same time, this method also allows you to control the permanent magnet synchronous motor with the sinusoidal back EMF. But then the average torque of the electrical drive will be lower by 5% and the torque ripple will be 14% of the maximum value. There is a trapezoidal control without feedback and with feedback by the rotor position. The open loop control without feedback is not optimum and may lead to the release of the permanent magnet synchronous motor out of synchronism, that is the loss of controllability. So open loop control is not efficient techniques. The closed loop control can be divided into trapezoidal control by the position sensing, usually Hall effect sensing, and trapezoidal control without sensorless trapezoidal control. So this is the trapezoidal control by Hall effect sensing. In this scheme we can use the PID controller, and we used pulse width modulation techniques and required the inverter and some switching device to make this trapezoidal control. So you can see the diagram of the trapezoidal control techniques. Now we will move on the second techniques, the field oriented control. The field oriented control, in short FOC, allow you to smooth, accurately and independently control the speed and torque of a brushless motor. For the operation of the field oriented control algorithm, it is necessary to know the position of the rotor of the brushless motor. There are two ways to determine the rotor position, by the position sensing, and second is a sensorless techniques. Sensorless by calculating the angle by the real-time control system based on the information available. The permanent magnet synchronous motor field oriented control by the position sensor. The following types of the sensors are used as angle sensor: inductive, optical and magnetic. So this is a schematic proper controlling scheme diagram for field oriented control of permanent magnet synchronous motor using a rotor position sensor. In this technique we can use the PI controller and PID controller and inverter. Field oriented control of permanent magnet synchronous motor without a position sensor. Since the 1917 sensorless vector control method of the brushless AC motor began to be developed. Thanks to the rapid development of the microcontroller, the first sensorless methods of the estimating the angle were based on the property of the electrical motor to generate the back EMF during rotation. The motor back EMF contain information about the position of the rotor. Therefore, by calculating the value of the back EMF is the stationary coordinate system, you can calculate the position of the rotor, but when the rotor is not rotating, the back EMF is absent, and at a speed and at low speed the back EMF has a small amplitude, which is difficult to distinguish from noise. Therefore, this method is not suitable for determining the position of the motor rotor at low speed. There are common techniques for sensorless start permanent magnet synchronous machine. So we will see this techniques for the next lecture, and thank you for watching the video.